We're going to look today at reduction and oxidation reactions. There's a shorthand that we use to describe these reactions, and it's redox. And that comes from taking the first part of the word reduction and the first part of the word oxidation to give us redox. So we've seen reactions like this before. So this is the displacement reaction between copper oxide and magnesium. In it, magnesium, which is more reactive than copper, displaces copper, takes the oxide ion from it, and becomes magnesium oxide. Copper oxide loses the oxide ion to become copper. Now, in terms of oxygen, we can describe the redox nature of this reaction. So the copper has been reduced because it has lost oxygen, and the magnesium has been oxidized because it has gained oxygen. So that's how we've described redox reactions before, in terms of the loss or gain of oxygen. Copper lost oxygen to become just copper, therefore it's been reduced, and magnesium has gained oxygen to become magnesium oxide, and therefore it has been oxidized. But we can also describe it in terms of electrons. So the first stage of this is to remove the oxide ions from this and come up with a ionic equation. Now the reason I can do that is because copper oxide contains a Cu2 plus and an O2 minus ion, and magnesium oxide contains an Mg2 plus and an O2 minus ion. So the oxide ion hasn't changed, so I'm ignoring it when I'm writing my ionic equation. What has changed is copper 2 plus has become copper and magnesium has become Mg2 plus. So now we can describe what has happened in terms of electrons because we've got these charges. Now, for magnesium to become Mg2 plus, it's got to lose electrons. It's got to lose negatively charged electrons. So magnesium to Mg2 plus has lost 2 electrons. And I'm going to use E minus there to represent electrons. Copper has been reduced because to go from 2 plus to 0, it's got to have gained 2 electrons. Remember, it's a little bit the opposite of the way we would think, because something that's gaining electrons goes from a positive charge to a neutral charge, and that's because the thing being gained is a negative charge, is an electron. So what we can then do is start to think about break these two processes down into what's called half equations. So I'm going to leave the ionic equation at the top. I'm going to write two half equations. So Cu2 plus becomes Cu, and Mg becomes Mg2 plus. And for Cu2 plus to become Cu, it has to gain 2 electrons. So those electrons appear in the reactants. So we've got gain of electrons, therefore they are in the reactants. For magnesium to become Mg2 plus, it's got to lose 2 electrons. So if we're losing electrons, they are in the products. And these are called half equations. They're called half equations because they show half of the redox process. Either the reduction, in this case, because there's a gain of electrons, or the oxidation, in this case, because it's a loss of electrons. Now, if we were going to summarize the two different ways that we can describe reduction and oxidation, we would do this. We would say oxidation and reduction, and we can describe it in terms of oxygen or in terms of electrons. So oxidation in terms of oxygen is the gain of oxygen and reduction is the loss. And it's the other way round with electrons. So oxidation is the loss of electrons, reduction is the gain of electrons. And for this one, there's a helpful little mnemonic, oil rig. So oxidation is loss, reduction is gain of electrons. Oxidation is loss, reduction is gain. And that's a helpful way to think about the reduction and oxidation in terms of electrons. And I emphasize that this is in terms of electrons. So to finish, we're just going to do a few examples of some half equations. So we're going to think about drawing a half equation for the following processes. So we're going to show the reduction of Zn2 plus to Zn. So the first thing we've got to say to ourselves is reduction is the gain of electrons. That's the first thing we need to say in our heads. So Zn2 plus is going to gain 2 electrons to become just Zn. Gain means that they are in the reactants. Let's have a look at the reduction of Fe3 plus, iron 3 plus, to Fe. So again, it's a gain of electrons. So Fe3 plus gains 3 electrons and becomes just Fe. And let's finally have a look at the oxidation of calcium to calcium 2 plus. So in terms here, we know that oxidation is the loss of electrons. So they are going to appear in the products. So calcium goes to Ca2 plus, and because it's a 2 plus charge, we have 2 electrons. Thank you very much.